Hello friends, in continuation with the last lecture, today we are going to talk about the description of the elements present in the basic functional elements of the uh, measurement system. So what are the functional elements which are present in the measurement systems? Do you remember? Something like primary element or the transducer element. It is also called as the primary and the secondary sensing element. Then the manipulation element. Then we can have the data presentation element and the uh, data presentation element uh, and the signal conditioning. Signal conditioning. There is also the calibration element as well as the external power source is required to drive these elements present in the measurement system. So let's see in detail. So the first element is nothing but the transducer element. It is also called as the primary and the secondary uh, sensing element. We can call it as, or these transducer element is generally at the primary and the secondary stage where it just try to sense the data and convert it into the any another kind of the uh, another type of the energy conversion, okay, we can say. And or else one form of the energy will be just converted into the another form. So this work is done in case of the transducer element. Transducer, we know that the transducer is the device which converts the one form of the energy into the another form or the same. So generally, these elements converts the one form of the energy into the another form, useful form of the energy. For example, input variable to the transducer could be a temperature, pressure, displacement, velocity, etc., etc. So these are the few input variables to the transducer, which primarily senses once the disturbances are happening around it or the changes are happening in that particular physical quantity to be measured. These are the something like a physical quantities to be measured, and it is supplied or the given to the transducer element, its sensor uh, sensing element. The output of this transducer element could be the current, voltage, or the change in resistance depending upon the transducer and its application. Means here we are just trying to use these type of the transducer element. Whether the output can be a current or else the voltage or else the we can have the resistance change of resistance change, and that also depends upon the transducer as well as the where we are utilizing it or using such a type of the uh, example. Now, what are the expected characteristics of the what are kind of the characteristics that transducer element does possess to utilize for the particular application? So it should have the good accuracy. Okay, now we'll see in the details the what is meant by accuracy and the related terminologies which will be useful. But it should have the good accuracy, then good reproducibility. Okay, so it should give its successive reading should not get changed. Then we should have the good accuracy. The reproducibility means we should reproduce the data in a good manner. Okay, then we can have the amplitude stability and the linearity. Amplitude stability means the whatever the output it is providing, it should be stable for a longer period of the time. And the linearity means there should be the one-to-one correspondence between the input and the output. Then the good frequency response. Frequency response, and that over the period of the time, if we are just trying to measure the that physically, available. Now let's talk about the another or the second element in the our functional diagram, that is nothing but the signal conditioning, and we have seen it, what is meant by the signal conditioning one. So what does actually it includes is nothing but the suitable modification in the signal parameters provided by the transducer element. So the modifications that depends upon the application where we are using such a kind of the transducer element. So the signal conditioning is very much important aspect in this section. So signal conditioning is that modification is required, right? So that it will be useful in the application. So it is very necessary. Why it is necessary? Because the output of the transducer is usually very weak. Output of this transducer is generally very weak. So obviously weak in the sense that the signal produced will be in the millivolt or the microvolt, and so and so forth, or the microampere or the milliampere, such kind of signal. So so that very weak signal is unable to drive the any kind of the display devices or the recorder or else the printer one, because its output strength is very weak. So it is not able to drive the big screens or the computer or the printer or the display devices or the recorder, because the pointer has to move on the mm, uh, paper, so that it can print the whatever the document or the record it has or information contained within it. So that's why signal conditioning is very much important in this case. So what it signal conditioning, what it involves actually. So what is composed of? So actually signal conditioning means we need amplification to drive these big displays or the recorders or the printers one. Obviously signal filtration, we need to remove the unwanted signal and the filter out the wanted signal for the particular or the specific application. Then electrical filtration, okay, noise is the particular electric filtration, or else sometimes we can have the excessive signal is coming, so obviously it has to be its amplitude has to be decreased by some kind of the electrical um, uh, circuitries. Then the signal compensation. Sometimes it is required to have the enhance the signal strength. So, or else we need to compensate the signal with the other signal, and actually that also comes under the signal conditioning. Then signal linearization. So, if there is a no one-to-one correspondence between the signal which we are measuring, then that also comes under the signal conditioning. It is also involving the differentiation, integration. Then sometimes we need to convert the analog signal or electrical signals into the digital format. Right, nowadays we are having living in the digital area, so obviously sometimes we require to have that signal to be in the digital form, convert to be the into the digital format. Signal sampling, okay, signal sampling also comes under this signal conditioning. Then the next element comes is the data presentation element, as we also know as displays as well. So the output of the signal conditioning element is presented in a user friendly manner. User friendly manner in the sense that it has to be easily readable by the personnel which it is which they are using it, or whoever is using, or the operator, okay, or else the whoever will be the, if operator gets changed, then the even that person also should get the information regarding that output which is measured. For the permanent record also it is data presentation element is very useful, means something like for the permanent record of the input signal or the graphic recorder, or with the heated stylus, or as the ink pen recorders or the magnetic strips are used in the data presentation element. Yeah. If output from the previous element is in the digital format, then parameter may be displayed on the digital display devices. um, okay, that comes under the data presentation element. What are the examples of this data presentation element? uh, is nothing but the video monitors, then the strip chart recorder, then the magnetic tape, then the different magnetic tape, something like, okay, we can have the something like ECG machine, right? That comes under the one of the example, right? Corresponding on this magnetic different panel meters, then the digital display devices, something like, nowadays we can see the various notifications or the advertisements on the roadsides, where we can have the digital displays, they are displaying the information or advertising the information. Okay. Now the standard measurements. What are the standard measurements are there, and where they are? In 1960, an international committee established a set of the standards for the length, mass, time, and the other basic quantities. Because before that, there was something like discrepancy in the standards they have uh, using for the comparison or calibration purposes. So, the uh, scientists have come together, had a meeting in 1960, and they have decided, they have come to the one conclusion that, okay, they can decide the some particular standard for the length, mass, time, and the other fundamental or the basic quantities. And what they have decided in this committee, which was established, a set of the standards for the length, mass, time, and the other basic quantities is called as the SI system, or the System International the units. In this conference, the committee has decided the units for all the fundamental quantities, and there are different types of the standards of measurements, and the classified according to their functions and the applications. So, which are they? The international standards. So, they have classified them. The first is the international standards, then the primary standards, then the secondary standards, and then the working standards. So they have decided these all three is under the that conference, right? So international standards, then the primary standards, then secondary, and the working standards, and they have categorized them, and decided some rules to follow to avail these standards to everyone. Now the first one, which is nothing but the international standards. What is it? The International Bureau of the Weights and the Measures at the Sèvres, France. Okay, so the Sèvres is the one of the place in the France, maintains the standards of the measures. So whatever the standardization or the calibration of the these basic fundamental quantities measurements, they are actually maintained at the Sèvres, France. Now, first basic quantity which we are going to see is nothing but the kilogram. So, or the mass measurements. So, it is the mass of the specific platinum iridium alloy cylinder kept at the Sèvres, France. Okay, so this is one of the alloy, okay, which is made up of the platinum and iridium, and its mass of the specific this alloy, cylindrical alloy kept at the Sèvres, is considered as the standard international standards for the kilogram. It is established in 1887 and has not been changed since that time, because it is and usually a stable alloy. So it is the one of the most stable alloy which is used for the international standards for the kilogram. The another fundamental quantity is nothing but the time, and its unit is the second. So it is defined as 9 billion 192 million 631 thousand 770 times the period of the vibration of the radiation from the cesium 133 atom in 1960. So the cesium 133 is its as mass number is given here. So cesium 133 atom, so vibrations, and how many number of the vibrations it should perform while radiating this much big number. If that many vibrations happen, then we consider that there is a 1 second is happening one. Before that, actually, it was defined in terms of the mean solar day of the 1900 year. Almost 120 years back, it was decided. Then the mean solar second was originally defined as 1 by 60 into 60 into 24. So 24 hours, 60 minutes, and 60 seconds. So this is how it was defined of the mean solar day. Then there was unit standardization or the international standards for the length. It is defined as the distance traveled by light in a vacuum during a time of the 1 by 299 million 792,558 meter or seconds. This much time period is considered as 1 meter, or the distance traveled by the light in a vacuum within this much time. 1 by almost this is nothing but the velocity of the light in the vacuum. That much distance is called as the 1 meter. During the 1960s, the length of the meter was defined as the distance between the two lines on a specific platinum iridium bar stored under the controlled conditions in the France. So these standards are not available to us, actually ordinary users, for the purpose of the day-to-day comparison, because now we can't directly go to how calibrate our maybe meter tape which is available to us and go to the France and just make the comparison and get it calibrated from that place itself. So it is not available to us. Then the next thing is nothing but the primary standards. Primary standards are actually constructed, designed, and calibrated by the national laboratories, similar and the similar organization. Just like the we have the National Physical Laboratory in the New Delhi. They do the job for us for the calibration or the standardization of the bars. Then all the devices under the secondary and the working standards are calibrated and certified by the primary standards maintained by the national laboratories and the standard organization, just as the National Physical Laboratory. These standards are also not available to the ordinary user for the calibration and the certification of the working standards. Generally, these are available for the some companies to have the calibration of the instruments. Then the next come is the secondary standards. These standards are maintained by the industrial measurement laboratory. Industrial measurement laboratory, just like we are having the scale bars in our compass box. Yes, they are calibrated from industries, and the industry calibrates their instruments from the national laboratory, and national laboratory calibrates their instruments from the that series France or as the international from the international standards. The main objective of this standard is to calibrate and certify the working standard against the primary standards. These standards are freely available to the ordinary users. They are freely available. But obviously, we need to follow some kind of the protocols as well. And then the last comes to the working standards. And general laboratories and the industrial measurements are calibrated by using the working standards against the primary or the secondary standards. These something like standard resistor, capacitor, conductor, cell, and the stainless steel filler gauges are examples of this working standards. Like secondary standards, working standards are also widely and freely available to an ordinary users. This is how the these standards are present, or they are categorized. Thank you.